Okay, so third session is on distribution network operation in with the DER and storage integration, role of distribution system operator. So may I request Professor Bose to please chair the session?
Okay, now that we've had a good lunch, we will try to keep you awake. All right? So you may have noticed that the last session, panel session, had a very similar title as this session. So you may be wondering what we are going to cover that the last session did not cover, right? So, but we'll try. All right. So let me start with I was just telling somebody at lunch that people who talk about operation and control as research, like at the university, my graduate students start with when they're going to do research on control, they start with an equation. All right, but I said, well, before you have an equation, you have to figure out what you're going to control. And to be able to do that control, you have to know what you need to know in terms of input measurements. And it is only after that that you start talking about equations, because the equations is the model of the whatever you're going to control, right? So I think you saw a lot of equations last time, so we'll try to avoid those. And we'll try to kind of also move a little bit about, say a few things about the general scheme of things, who controls what, and which are the organizational things that come into play, and so on. So the way we will do it, let me first get the introduction. I've got big, long resumes of people, which is expected because they're all very well known to you. But because they're well known to you, I'm not going to spend a lot of time reading their resumes. So, but let me at least give you short introductions to them. And I will introduce them in the order I'm going to ask them to talk. Okay, so we will start the session with Mr. Saxena. Okay, and he, as you know, is the Senior Fellow and Senior Director of the Electricity and Fuels Division of TERI, and he's graciously hosting us over here since his office is right next door. And he has a long list of experiences and so on. He's worked in both on the policy side, as well as engineering side, and he has worked in various capacities at Central Electric Authority, the Ministry of Power, and CERC. The next person I'm going to ask to speak is Professor Abhyankar. And as you know, he's a NTPC chair professor at IIT Delhi, and he serves on all kinds of very important committees. Probably the biggest one of them is Global Future Council on clean electrification of the World Economic Forum. Okay, and he's very well published and he's very well known. So I'm going to ask, the next speaker is going to be S.K. Suni. And again, another person who doesn't need much introduction. If you think of the system operation in India today, he was probably the architect of it, most of it. So, I will let him kind of say his view of this thing. But let me just see some of the awards, tell you some of the awards he has. He's a Life Fellow of the Institution of Engineers. He's a Fellow of the IEEE, a distinguished alumnus of IIT Kharagpur, which is my alma mater. He's a distinguished member of SIGRE He's a fellow of the Indian National Academy of Engineering and also an international member of the US National Academy of Engineering. Okay, and then we will have Mr. B.V. Mehta from the Odisha Power Transmission Corporation, and he's the chief load dispatcher and a director there. And he also has been in this industry for a long, long time. And previous to Odisha, he was a long time in Gujarat, the SLDC. He was the chief engineer for the SLDC in Gujarat. And he will bring up the rear. And I say that because that will kind of give you a pretty good idea of what's happening in distribution operation in India itself. Okay. And we're not going to, there's two of us from the US here. So the next speaker is going to be Rob Hovsepian from the National Renewable Energy Lab. And he's also, he's worked many, many years in research. He has a master's and PhD in mechanical engineering from Florida State University, and he's worked for many, many companies like General Dynamics, TRW, Northrop Grumman, and so on. But mainly he was a program manager at the Center for Advanced Power Systems for the Electric Ship Research and Development Consortium for the Office of Naval Research in the US. And so he will talk about, again, distribution operation, and I'll bring up the rear. And there's only two of us from the US, so we're not going to be able to match the breadth of experience that you're going to hear about the Indian side. But that's how we're going to run it. And we're going to try and leave some time for discussion, and it's a small group of people here, so we should probably have sort of an open discussion on what is going on. As one of the things that you do know is everything in the distribution side is changing, and changing rather rapidly. And one of the things that we'll have to do is to adapt our operations to that change. So with that, I'll turn it over to Mr. Saxena.
First of all, I would like to thank Professor Bose. You made my job simpler, because I was also thinking that what am I going to speak about the distribution system operations when people have covered it so exhaustively. And I took a photo of what Professor Abhijit Mahapatra presented. N number of distribution functions he has already sort of spoken about. So what are the functions I'm going to talk about? I think that was very sort of a thank you so much, Professor Bose. And second time, thanks to you that we are not going to use any equations. This alpha, beta, gamma, I don't know much about it, and I'm not going to use them. So thank you so much for making this also easier to us. Now, this session is on the distribution network operation with the DER and storage integration and the role of DSO. So I'm trying to give you a glimpse of what has been the sort of the evolution of the system operation in the country. And many of us who are here in this sort of a hall have witnessed the evolution of the system operation in the country. Myself, Mr. Suni, and quite a few of them who have seen it, how it has evolved. And when we started, I think first of all, I would like to say that the distribution is a licensed activity as per the Electricity Act. So now the question becomes on the distribution system operation. What does it happen to the distribution system operation? And the primary responsibility of the distribution company is to maintain the continuity, the reliability, and the quality of supply. How far they are able to do, with how much degree, I think it all depends on the tools and tackles they have, the skills they have. And in the times to come, this is going to become more and more important. And with the increasing penetration of DER, this is going to be all the more challenging and complex. That is what it is. And we have seen over the years that the organization which was responsible for the operation of distribution system has evolved with the evolution of the power system and the structure of the power system in the country. We had the state level systems and we had the state load dispatch centers. Then we had regional grids were formed mid 70s. Then the regional load dispatch centers came in, and then came in the national load dispatch center. And now we have a full-fledged hierarchical setup of control centers in the country with NLDC at the apex and the RLDCs, 5 RLDCs, then the SLDCs. And we have seen in the LDC award function about 43 load dispatch centers are there in the country today who were eligible for that award. And if we talk about the distribution level systems, I think they are going to be many-fold. About 70 plus distribution companies are there. And what we as part of the project team think about or envisage about, that every distribution company is going to have a distribution control center in the times to come. Now, this is a key question. Many people still feel whether they are the distribution control center or a control center are sometimes are there in some of the cases, but people think whether the DSO is needed or needed. This project is aimed at looking at the need and relevance of DSO, why it is needed and what all it is supposed to do and what all it is supposed to bring together. Now, I would like to only say as an answer to this point is that we have seen the control centers which are there at different level. Their functions are very well defined. Their jurisdiction is very well defined, and their inter-control center coordination or between the various hierarchical levels is very well defined. But this is an era of specialization. We can't say, there is often a discussion, and I have heard about during the lunchtime or the dinner time after a conference, that why there should not be a single control center in the country. People say, can NLDC not control it? I leave the question open to you. I think one can think about it. But I am a strong believer of the fact that the specialty brings the special requirements and skills to be there. And now, can a national level control center measure the pulse of the distribution level system? What is there? What is happening at the distribution level? It is just not possible. And with the increasing penetration of renewable, I will just give an example. I think Mr. Soni will, all of us know about it. 9 p.m. 9-minute event, and everybody estimated how much is going to be the fall in load on account of this in the residential category, and how sort of a wrong or error was the understanding of the distribution companies to gauge the quantum of load which will reduce on account of this. So this is what is the only, we don't even know the quantum of the load which is there at what point of time. So what to talk about other things about. So the consumer behavior behind the meter happening, what is there, etc. A lot many things are there, and we don't have even the metering, etc. to do that. We also heard Mr. Soni in the National Power System Conference that the energy accounting today in India is done with only 1% being metered. Rest. But it is happening. It is happening in a transparent manner. It is happening in a dispute-free manner. So I think we have to move and we have to learn, but gradually we have to go to the automation, which is very essentially required. But I think what will be required is that as we will move from the sort of a one type of level of operations to different level of operations and complexity, I think we have to be evolving in the form of the organizational structure also, and the automation required for the same, and then gearing up for meeting those challenges. The functions are very well known to us. The prominent ones we know about, that reverse power flow is going to be there, protection requirements are going to be changing, behind the meter scene is not very well known to us, the harmonics are going to be there. So a lot many functions will be there which are required to be sort of performed by the distribution utility. Now, the relevance of distribution system operator, to my mind, it is very much there, and it is time now that the distribution utilities in the country start taking note of it. I think maybe fortunately or unfortunately, but the state of the facts is that the distributed energy resources, the penetration is still very low in our country. And that is why people are not realizing the entire renewable energy constitutes about 10 to 11% of the energy mix in the country, and the distributed level energy injection is very little. I think people are not realizing the importance, but it is time for all of us to get together and understand and disseminate and communicate that this is going to assume increasing importance, and we should gear up for that. With this, I will leave it to the other speakers to go into the further details. Thank you so much for the opportunity. Thanks a lot.
Good afternoon. Thank you so much, Professor Bose, for introducing me, and Saxena ji for laying down the foundation of the discussion points that we would be doing in this session. The problem with this panel and with me is that whenever you are in a panel sitting with Mr. Suni, if you speak ahead of him, then people start feeling jittery, that, and even I get a feel that, okay, I'm standing between, people and Mr. Sune's talk. And if you speak after him, then you get a feel that, okay, what is left now? Everything is covered. That's the problem. But sir, please, with your permission, I'll just venture and try to provide a few key points so long as market aspects of system operation are concerned. So Professor Bose mentioned about the equations not being used. So there's one funny incident I would like to just, for a minute, I'll just take a minute to tell you about this funny incident that happened with me. I teach a semester-long course in IIT Delhi on restructured power systems. And most of you know that there's a term called social welfare or a societal welfare. And in markets, the markets are cleared using this term or the objective of maximizing the social welfare. And to us engineers, it's a pakka mathematical expression, right? But then about 10 years back, when I taught this, I was teaching this course, there was a parallel course that was being taught by a professor in humanities. And that course also involved a term called social welfare or a societal welfare. So the students in my class, they started cribbing that the social welfare that you are talking about, our ma'am in humanities, she tells us that your professor does not know anything about social welfare. I said, why? This is what the mathematical framework is of the optimization mathematical programming framework, and it is pretty clear to me. So I went to her and I spoke to her that why did you tell like this? Is there anything wrong with this? He said, yes, everything is wrong. You don't understand the spirit of the term social welfare. You take it only in mathematical way. But why is it called social welfare or societal welfare? Have you ever given a thought to this? So it was an eye-opener for me, and I thank that lady. Then I started teaching this course in a different way, started, telling about electricity being a commodity rather than a service. So if you start treating electricity as a commodity, which has got very special attributes to it, then in that case, the spirit of this societal welfare can easily be understood. Why this mathematical expression is really called societal welfare. Anyway, so let me come to the topic of discussion. Now, I have slides, but they really are meant to keep you engaged. That's it. If you get bored by what I'm discussing, the slides, you can read the material on the slides. Whenever we talk about markets, the days have come where we simply cannot ignore the market aspect of system operation. Markets are very much an integral part of system operation these days. Power systems has operated without any deregulation or markets for more than 100 years. But if you see today's position, electricity commodity markets, they have achieved a long penetration, deep penetration into the system operational aspects. So my focus of this talk is on touching upon certain aspects of this added dimension to the system operation. However, whenever we talk about electricity commodity markets, the general feeling is that of skepticism. And this I have been witnessing since my PhD days about 18, 20 years back. Whenever at that time, the enactment of Electricity Act was about to happen, and establishment of power exchanges was under discussion. But hardcore power engineer used to feel a kind of resentment towards this term market and deregulation. I have witnessed this, right? But now you see slowly the change has taken place, and now we have markets at the wholesale level. My urge to all stakeholders and all power engineers, policymakers, regulators is to understand the importance of markets when we talk about the DSOs or distribution system operators, which we easily can see that few years down the line, we will have DSOs in different variants being established in the country. So this air of skepticism is something that we should be doing away with and start looking at markets as an integral part of any scheme development, so long as local level markets are concerned. So I'm specifically using the term local level markets thanks to Professor Anup Singh, who is sitting over there, because we used to loosely use the term retail markets. But then he pointed out that in Indian context, retail, the word retail, refers to a different activity altogether. So let's start calling it local level market, which is so appropriate. Now, why should we have local level markets? Because true potential of DRs will come out only through market mechanisms. There is a whole list of reasons why I can show you why we should have markets. If you don't have, now in the wake of large scale DRs being integrated into the distribution systems, and if you don't provide them with an opportunity to trade their electricity commodities, the 100% juice cannot be extracted out of these DRs. This is something that we must understand. It is like building a Ferrari and then asking it to run on a narrow and roads with a lot of congestion. Makes no sense, right? So that's why we should have local level markets whenever we are talking about the DSOs in place. Now, whenever local level markets are concerned, there are two classes of commodities that are usually talked about. One is the energy and the other is the flexibility. Energy related commodities and flexibility related commodities. And flexibility is something which is very, very, very peculiar to the DERs and the markets associated with them. So I was having word with Michael Pessin of Department of Energy in US during our last UI Assist meet. And I asked him a hypothetical question that, let's say if you have 100% penetration of renewables, the entire grid is running on renewables, there are no conventional generators. How do you plan to manage and maintain the grid security and all that? He said that we'll go to flexible loads, because flexible loads would be the ones who would allow us to play around with certain variables, and then we plan to do it like that. So how much of truth in that is there? Time will tell. But then one must understand that the inherent flexibility within these DERs is something that needs to be exploited, and then it needs to be traded with different entities at the distribution level or the transmission level, and so on and so forth. These commodities, they have got multiple beneficiaries, like of course DERs, DSOs, TSOs, and prosumers. Now these are different institutional entities. The regulations which control and the regulatory framework for these entities are different. So in India, the problem is more complex because we have central regulatory framework, state level regulatory framework, And if we talk about, making the flexibility embedded in the distribution system available to the transmission system, then we have to think about how do we come out with appropriate regulatory rules to handle this. Now, while developing local level markets, the most important question any market designer would ask is that should this be developed on similar lines of wholesale market? Well, the answer is not digital yes or no types. There are many aspects that you must consider before asking this question. You must understand why wholesale markets came into picture and why do we propose to have local level electricity markets. And for that, one must understand the pillars of market design. Okay, I'll just skip this slide. I already spoken about it. Yeah, this slide is important. This slide is essentially, I would say that this is one of the most important contributions from UI Assist group. So long as development of local markets and its integration with DSOs is concerned. Now I'll quickly explain what exactly is meant by pillars of local level electricity market design. So most of you may be aware of the four very popular pillars of market design proposed by Sally Hunt for the wholesale market design. These are called pillars of market design because they have got direct bearing on the system operation. How? Because every pillar gives rise to a separate set of market for that commodity. So every pillar creates a different commodity, and then there is a separate market mechanism for that commodity. I'm talking about wholesale market level. And why these pillars are important? Because if you give due respect to these pillars of market design, it leads to consideration of market architecture. Market architecture is nothing but a map or a layout of an interlink. Oh yeah, this slide is important. I'll just take, yeah, sure, thanks. So market architecture arises out of pillars of electricity market design. Now, if you see here, what we propose as part of our work on DSO is 4 pillars of market design at the local market level. Scheduling and dispatch is, of course, will be there if it is wholesale or retail, local level market. Important aspect of scheduling and dispatch pillar is temporal and spatial granularity. So it's a very challenging problem. How do you introduce the spatial granularity to what level and temporal granularity to various products or various commodities arising out of DERs? Then there are discussions on pool or proposals on pool, P2P, bilateral, multilateral type of a market and platform and all that. Flexibility is something which is very important pillar. Now, in the conventional pillars, there were imbalances, congestion, and reactive power or ancillary services. So all these 3 are combined and they go and sit in what is known as a pillar called flexibility. Please note, flexibility is important because we have, and there is a combination of congestion, imbalances, etc. within the flexibility, because in distribution side, we have what is known as a default service, right, which is not there at the transmission level. Then you have settlement, where metering and billing is an important activity, and one must understand large order of magnitude over there. And DSO coordination is a very, very important aspect. The appropriate framework tells you how can you give access, global access to the DERs embedded within the distribution system, so long as trading of commodities is concerned, either directly or indirectly through minimal data exchange. So this is important aspect. And then based on this, we had proposed 4 institutional frameworks. I'll just quickly read them out and stop. So option A, so as part of our work, UISS team proposed that if DSOs have to come in India, there are four possible institutional frameworks that we can talk about. One is repackaging of existing and new entities. That could be option one. The other could be sub SLDC to DSO transition. We call it option B. Then existing DISCOM to DSO transition, which could be a very popular option for the urban DISCOMs. That is option C. And creation of a separate non-profit entity called independent DSO, independent in all respects, is option C. So we call them model A to model D transition. We call them as transition from shallow to deep DSO. Okay, yeah, I think I should stop here. Maybe we can discuss later on. Thank you. Thank you, Professor Bose. Yeah.
Yes, sir. Making me nervous, sir. Sir. So, sir, thank you very much. Thank you, Chair, Professor Bose, and all the co-panelists and all those who love DSOs are here. So, challenge before me is within 10 minutes, I have to make 10 points. First point. First I heard about DSO was 2007. I had not heard of DSO before that. And that was in a meeting in East Coast in US where all the grid operators of the world, large grid operators, had assembled. Interesting thing about that, it's a long story, but I can't take more than a minute. The first person who raised about the DSO was Terna, Italy, followed by NGC, UK. And you will still find most of the papers from them. I have put a Google alert for DSO. Every week I get around 10 papers on that. US has not done that much of work on DSO. I have some understanding of it, but we would like to hear from others that why DSO concept is going fast in Europe and not in US. Okay. So the DSO concept has been in circulation for about a decade, 15 years or so. That's it. It's jurisdictional dependent, geography dependent. One size fit all will not work. All these are known to us. Need not repeat all that. DSO is going to be a knowledge industry. The way the load dispatcher is a knowledge industry, all the equations which you people make, optimization, we are the one who implement it. And that's where the rubber meets the road, and the theory meets the practice. Same thing has to happen in DSO. From research stage, now it has to be in deployment stage. We need to raise the maturity, the readiness level so that it can be deployed. What is to be done for that? Policymakers, regulators, including politicians, they need to be convinced that this is required. For that, we need good documents of all kinds, from academic side, from social side, and from all other things. The next point I would like to make is, in India is a subcontinent. Federal structure, large footprint. How many DSOs you feel would be there in India, roughly? Rough number, just quickly, anybody, any number. I don't know also. Huh? 70 plus. 1,000 plus. Anybody, any other number? Germany has 600 DSOs. I stop here. You can think what it will be for the country. I don't know. I am ranging anywhere between, it could be a 3-digit, 4-digit anyway. That's the kind of an uncertainty with which we are, living. The report has beautifully come out, but my only regret is why is it not getting delivered? So delivery pangs are there. So it should quickly come out in the public domain so that people read it and we start implementing it. I'm an impatient practitioner. So we need to convert it. We need to convert very, very fast. So now I will talk about TSO, DSO, ISO, DSO coordination. So Mr. Saxena already mentioned about that 9 p.m. 9-minute event, but let me again take. It was on 3rd, Honorable PM makes an announcement that on 5th April, 9 p.m. for 9 minutes, everybody will switch off the light. You can imagine what happens to me. I was trembling before the TV. But, kya bol rahe? Immediately, by that time, COVID taught all of us about this remote thing, but grid operators, technology-wise, within half an hour, 28 control centers were online, video conference, and that continued till 6th morning. Remember, more than 60 hours. Mehtaji was also there. We all assembled. Now, what was the challenge before us? Challenge before us was that how we will manage within 9 minutes. All these fundas were known to us. Thermal ramping is not there, hydro ramping is there, start, stop, unit commitment, network congestion, and who will be having all those things very easily. Every generator was brought on bar one by one. Please do show us that you can do it in today night. Tomorrow you have the final test. See, the perturbation, I have heard perturbation many times, in power system we use. But perturbation means anxiety actually, if you look at it. So the anxiety was that there going to be disturbance for 9 minutes and then we have to come back. Why I'm telling you story, I'll come back and join the whole dots. So people started estimating first, how much will be the load changeover within 9 minutes and just draw that, then we will manage. Best of brains in India were working on it. 5 methods we found out. One, how many residents are there? Second, from the old curves, find out that what will be there. What were the different methods, every person was applying his mind. And we all came out with a range between 13,000 to 15,000. Correct? So I said, put 50% margin. They said, why is that 50%? You have taken the maximum, but still, So that was our estimate. It will be very interesting to show all those papers, all the research. And I said that how many MTechs are here in our organization? Who are there? Please apply your knowledge. Tell me the right figure. So 15,000. So we have planned for 15,000 megawatts. Okay. What happened actually? 31,000. Why did it happen? Around 400 engineers of all SLDCs, RLDC, and they were best of brains. You all have taught them, right, students? So we realized that as grid operators, we are not close to the ground. We don't know the behavior of the. We know 100 megawatt, 132 kV, this, that, and all that. Consumer behavior, we are far away. And even distribution utilities also don't know. Even the people who administer in the state, we consulted all of them. We bounced with everyone. Sir, ठीक है ना 15,000? हाँ, ठीक ही लग रहा है, ठीक ही लग रहा है. सब आदमी ठीक है लग रहा है. तो 31,000 हो गया. So that has made me, completely convinced. First to admit that we don't know this consumer. Distribution level requires different skill set. It requires different set of data, different kind of analysis. You all have done modeling. I know that load flow doesn't run, this radial distribution doesn't run the way we run it, but it requires a different set of things. And hence, there is a need for this. All the research which you people are doing, you will need a vehicle, you need a platform through which you will get it implemented. And that is DSO. Now, any such institution building takes time. And my unit is decade. Nothing happens before a decade if the idea is good. So the DSO will take a decade or so to at least evolve in India. We need to start as quickly as possible. See, there are many things which have happened. For example, in the market. And then competition is what we have been discussing. Competition of how we say smart grid. Everybody talks about smart grid. What is smart grid? If you smartness just has to be seen in the UPI. Look at the way you are buying vegetables. Look at the way you are exchanging money. And that is only market. I am not talking about the physical side of it. So our competition should be with them. FinTech has to come in the DSO. Now, I will switch over next 2 minutes is that OTC platform is already coming. We are talking about a high level of IT and all the such things. What is the future other kind of a thing which you require? Market and all those things Professor Abhayankar has already explained and he is the best person to explain. I can't. But on the physical side, all our peripheral load centers, important load centers, be it Kolkata, Mumbai, Chennai, they are all in trouble. Why they are? Because there is a population high density load, you can't have generation there, and so on and so forth. And we have technology, PMUs are there, micro PMUs are there, many relays have the PMUs. Transfer capability is a concern, can't reduce generation. If you import, then there are issues. And all these centers have been facing disturbances. I have talked to all those distribution experts. Now, they don't understand the grid and the grid does not understand them. A perfect case for DSO, ISO interaction. That if you can, you make them understand that you only look at the angular separation, look at or put it as the strategic location. I'm just giving you one idea. But the ideas which I saw in the morning, so many, each slide, is full of ideas. Give it to them, give such institutions, equip them with proper manpower and skill set, they can do wonders. So DSO as an institution has to be built. It will be step by step. It will be a journey. And as I said, at least 100, I think there is a consensus, nothing less than 100 DSOs. And if each DSO even has got 5 good power system engineers, so you need 500 good engineers. So a lot of work to be done. All the research things can be deployed there. How it will get deployed, we don't know really. That only time will say. But we need to deploy that. There is no doubt about it. And I have been telling about everyone. Right, whenever I have got an opportunity, right from minister to secretary to everybody. So now, for last 6 months, they are asking me, "Kya hua tumhara DSO?" And so that is the situation kind of thing. We have an opportunity of electricity bill getting amended. All of us like vote, write 10 lines, please insert DSO somewhere. Something like this has to be done so that, the action is at distribution now in India from all angles. Whether you talk of DER or financial viability or whatever we may talk. So the distribution is the one and the DSO is a very important institutional arrangement which is required. Thank you very much.
Right. Good afternoon. In fact, Professor Abhin sir has rightly said there is nothing left after Soni sir has some views or the advice or the talk. He has been my mentor since years. I am privileged to have a sharing the dais with him. Nothing more to share with you. Since morning we are talking about DSO, distribution energy resource, lot of issues related to that. I will make an humble effort to share some practical points which we face or we come across with this. I think this can be stripped out the evolution of DSO, what were the performance or the goal established for that, what were the technology deployed, and what application we did way back to 1980 up to 2020. Certain uses of demand distribution management system in the DSO is also described. I think everything has been talked in the past lectures. Even who are the players in the DMS, what were the ADMS, who are the component thereof is also known. This is advanced distribution management system functionality, very much in detail described, but can be learned out of it. For the want of time, we'll come directly to the issues. These are certain advantage of ADMS. It helps the distribution company to perform better with optimum solution like that. These are really scenario with respect to India. No observability of the behind the meter power. We take an example of Gujarat, 1000 megawatt, I repeat the word, 1000 megawatt plus rooftop solar in the state of Gujarat. How they might be managing. They have no visualization on this. And it has a 2-3 type of effect. I will tell you that DISCOM is unaware of the exact power requirement. Specifically, what happens when there is a load restriction is imposed? The generation on that distributed energy resource also gets zero. So why do we impose the LR? because we have deficit of the power. And we add a fuel to the fire by switching off the feeder where the consumer is there, also the generation is there. Because we don't have separate feeder for that. That is a rooftop solar or ground mounted solar connected with the grid. So this is a thing we have to give a thought on that. Technical way to find out a solution thereof. But during the load restriction today, the rooftop generation also hampers because the inverters over there are a grid frequency connected inverter. Unless the grid is zero, they will not generate anything. And banking of rooftop generation creates operational and revenue problem. Let us take a 2 minute. Who is being going for a rooftop solar? Sir, the person who has a roof on his head. वो कोठी वाला है, tenement वाला है. Husband and wife both are earning at least 1.5 lakhs per month. Income is there. We give them a subsidy to put 3 kilowatt solar panel, 1 lakh rupees subsidy we are giving. Things doesn't stop there. In daytime, they are not at home. The rooftop inject the power to the grid and poor distribution company has to absorb it. At the evening, they return back from the work. During night, 3 air conditioner operates. पिताजी का चलता है, बच्चों का चलता है, दोनों couple का चलता है. And for which the poor distribution company has to buy the power 12 rupees. And that injury is not for a day or two, sir. It is for next 20 years, 25 years, the lifetime cycle of the rooftop solar panel. So we need to give a subsidy. बहुत प्यार आ जाता है तो let us बीबी मेहता 50,000 का चेक ले लो. But don't give him the instrument which kills you every day. Which kills you every day. And this is the fact, sir. Say, I am not against the solar generation, renewable. But the mechanism we have to establish, भैया 15 मिनट में आपका जो generation है, you consume it, otherwise it will be absorbed by the DISCOM as an inadvertent flow. We won't pay anything for that. We are not a charitable trust. So this is the fact, sir. We have to take a look on the policy or incentive which we plan. Because say, I don't think that we have to give any subsidy to the people or a couple who wants 30 lakhs rupees per year. There is no need of it. And now this banking issue, I said, with real-time market, wide variation in the industrial consumer demand. So DISCOM is being pinched, penalized, put in the trouble with respect to operational aspect, with respect to financial aspect. A 10 megawatt industry will buy the power from the real-time market when the market rate is less than the consumer tariff. And he will immediately switch over to the consumer. At that time, DISCOM has to buy the power when the market rates are more. So today as a distribution company, it is really impossible for me to define. Suppose 400 people has taken an open access approval from me in the state of Odisha. How much they will buy in the RTM? Tomorrow in which block? I don't know. I am left out with the result of the RTM market only, sir. And I have to manage at the higher costly power. Whenever the rates are low, they will switch over to the RTM. When the rates are more, they becomes a consumer of the distribution company. So let us think about that. This is penalized and pinch, not only for the operational point of view, use in the revenue. See, we are thinking of making the distribution company on their foot. Lot of central government scheme has been trained. Technology has been provided right from RAP, DRP, IPDS, RDSS. But the real problem which we are creating by introducing certain new things where the DISCOMs are never consulted, where DISCOMs are never confident, or even knowingly, we should have some restriction that if you want to switch over to RTM, don't come back as a consumer to us. If you want to buy the power from open access market, don't become my consumer. You give me fixed charge only, but that is not happening. Now let us think one step ahead. When the consumer buys the power from the RTM or the day-ahead market, the distribution company has to surrender his allocation. When it is being surrendered or back down or surrender is there, they are supposed to pay the compensatory tariff to the NTPC or a central sector project. So if I buy less, I have to pay some compensation and my end cost will increase. If he buys, he gets benefit of a lower market rate. Sir, both are the buyer. How an unequal equation is put to both of them. And this really matters a lot. And uncertainty is one thing. Operational problem is another thing. Revenue loss is third. And fourth one is that because when the consumer is buying from the market, my requirement of power reduces drastically. At that time, I will surrender my central sector allocation. So NTPC will charge if I operate below 85%, then they will charge the compensation that rise up to 45 paisa. So it hampers the distribution company. Wherever the DISCOM is a direct buyer of this type of power, fortunately in India, what happens, there is a middleman called a holding company. In a Gridco or GUNL is there in our Gujarat. They absorb this buffer. But truly speaking, this buffer is killing the viability of such holding company or a DISCOM. So we have to take a call on such things. Large scale presence of EV may cause high demand at the peak hours, and people people shall charge on returning from the way by the 7 to 9 p.m. Say we are promoting the electric vehicles. Well, it's a very good thing. But let us study the behavior of the Indian people. My wife has an electric vehicle. She comes from the home at around 5 p.m., 6 p.m. Immediately she plug and charge. It is the highest tariff at which the DISCOM is operating, sir. Now think that 2 million vehicle in the capital city of Delhi, sir, after 5 years. Down the line, say 6 years. If all 2 million vehicles are put to the charge by 7 p.m. to 10 p.m. in the night, what will happen to the Tata DISCOM, BSS Rajdhani? From where they will get the power? Renewable is not available at that time. We have to go for a flexibility of generation. We have to go for a storage, and we have to simultaneously design the switching mechanism of the this charger of that vehicle. It won't charge before 1 a.m. Unless there is an emergency for me, then there will be a bypass switch will be there. Let us take a holistic view. If you think in a bigger way, there are realistic problems which DISCOM is going to face. And by introducing such thing, so it's not that we should not integrate the renewable. We should not use the EV. We need to control our pollution. We need to use the EV. But the issue or the problem we anticipate in a large way, we have to try to mitigate a probable, workable, implicable solution thereof. Daytime charging is practically not feasible. Say there are states, there are countries, US, the parking space is there. In each parking space, there is a charger is there. Sir, in India, we don't provide parking space to our employees. So that is practically impossible thing in India to come up. How many institute will have parking space available to their industry employees? Very limited, 5%, 10%. We should deploy the methodology to get the RE power at the time of EV demand, maybe by storage or a banking. Banking, maybe some needy state will give me the power during evening. I will give power during daytime from the renewable. And last but not least, very important. So TOD is not there in the country. We have rolled out millions of smart meters throughout the country. Even a smart grid nation project deployed at each state web at 2017-16. Almost it is a failure model everywhere, including our Gujarat, Naroda town was there. Who has earned out of it, sir? Hardware supplier, hardware AMC, ATS of the ERP software, and the system integrator, and the telecom company. Because as a distribution divisional engineer, I had no right to deviate any equation or any concession to the consumer because tariff was only a single tariff of a 2-month total energy consumption. No other features were there. So a time has come, sir, when we know that we need to harness the renewable. My major renewable component of the solar is during daytime. So our TOD system or the commission or regulator should come forward with a special concession during the solar hours and penalty or higher rate during the evening hours. The time has come and we have to take a call on that. Then and then only DISCOM will be a sustainable, stable model which will be persisting for a long period. The distributed RE generation to be consumed, it is available or it is managed to be stored by the RE or distribution developer. Say, if you see the Gujarat solar policy 2019, I suppose, the policy is very clear. You go for any capacity of ground mounted solar, but you have to consume between 7 a.m. in the morning to 18 p.m. 18 hours. There will not be any banking of this power. If you consume beyond 18 hours, you will be charged as an industrial tariff. And during daytime only, you can set off your power requirement with respect to solar. so the distribution viability sustains, maintain. And only one last point is there. Now, with a very high level propaganda and push of the solar and renewable, unlimited capacity of rooftop solar has been permitted in many states. Sir, it is much more than the distribution transformer available at your society rate. And during afternoon, it cannot step up beyond 75 kVA, 100 kVA, 200 kVA. That limit is it. And Discom has no revenue source. CapEx and OpEx, they don't have for such things, sir. So these are certain issues. I will take only 1 minute, sir. I think this conclusion is known to everybody about the distribution management system, etc. Sir, I humbly try to share the practical issues which you face. Thank you very much.
Thank you, John, for the introduction, and thank you, ESS, for inviting me. I'm just going to give a quick overview of what's the advance of the DMS system, what our things we're looking for. In the DMS system is a distribution management for allowing us to do both measurement and controls. Its measurement is coming in from the SCADA side of it. I apologize for getting too simple here, but it's as early, late 1980s, 80s, 90s, we started looking at the data acquisition system in manufacturing, which we took that one and developed it into what became the TRW SCADA system. That was late in the 1980s. And from that point on, the SCADA system stayed stagnated at that time. And the manufacturing execution, the manufacturing data acquisition system became a data acquisition system. It became this computer-aided manufacturing system, manufacturing execution system. As manufacturing sector was evolving, so did the SCADA system that came in from the advanced manufacturing to become more advanced control system. Meanwhile, the SCADA system within the power system stayed stagnated. But as we started getting the DMS tools, getting more and more advanced controls in them, it would start requiring that for us to go ahead and create a DMS system, which is what started the DMS system. So as our power systems becoming more advanced and we're seeing more IoT devices, more controllers that are interacting with each other, it's going to start requiring why DMS system is needed. So right now, today, if you have 4 or 5 devices that are interacting with each other, it's the norm. But as we get more and more, the distribution system becomes more advanced and more control systems start interacting with each other. We're going to have hundreds or even thousands of those controllers that are interacting with each other. So with that, it's going to require more of an advanced DMS system in order to be able to understand how all those devices interact with each other. And in order for us to do that most of us at the university level, we have a laboratory scale where we have fixed data, but we have also ability to create a lot of different algorithms. Look at the algorithms that we need to develop. So it gives us a flexibility to evaluate various algorithms, but we have a fixed set of data. On the other side of the extreme, on the right side of this figure, what we're seeing is the utility level where you have a lot of data or different type of data, but we have very fixed algorithm. We don't have flexibility to go back and change those algorithms. What we need as we start getting our DMS system becomes more and more complex and becomes more and more advanced, something right in between that allows us to create that real world environment, allows us to create more ability to change the algorithm while utilizing the actual variability of the data. So creating the real world environment in a control area that allows us to do rapid prototyping of this advanced next generation control system. And that's the direction we're heading with advanced DMS systems, to start looking at it, how those systems get interacted. And that's why we're looking at it at most of the things that we see at the UISS here and with ARIS, what we're developing at NREL, is allows us to do that. So what we're creating, last time when we had the annual meeting, we had about 50 IoT devices or RTU devices that were set up as part of our digital real-time simulation system. So since then, we multiplied that by 10. Right now, we have 600 devices that are all able to communicate with each other, IoT devices at the various control and communication protocols that are connecting it. And our goal is multiplying that by another 100. So by end of FY23, have 5,000 devices. That start becoming more realistic, what we anticipate to see future DMS system. The future DMS system will be more and more control devices, IoT devices, your cell phone, your vehicle, as the example that the gentleman before me was talking, they're going to start interacting with each other. So we have to create that environment that allows us to do that. This is one of the examples. The setup that we're setting it up is at NREL. I think Anurag talked about this earlier as part of the Team 8. While we're doing the work is creating the digital real-time simulation, the cluster of large digital real-time simulation system, which has the various battery storage and AMI devices and various PMU and micro PMUs. So what allows us to do is create the so it allows us to create the So it allows us to create an environment to create various controller and rapid prototyping of those controllers. So the same thing could apply for the DMS system. So this is the environment that is creating its, and that's becoming more and more popular in international labs to start creating those environments. This is an example of a project that we're looking at it where looking at a distribution system allows us to see how do we segment or create a zonal system within the different within the DMS systems that allows us to look at the zonal approach for survivability and increased resiliency of the system. This project is going quickly on those slides, but I just want to give time for our questions. So this is a project we did, for example, in the part of the UISS, we looked at how do we create that controlled environment. So this is going back, creating controlled environment to do a rapid prototyping of the controller. So in this case, that's the environment that we use in order to develop the controller for the UISS project. Now, what I'm going to go talk right now, I'm quickly 3 examples of what are the kind of things that we anticipate in advanced DMS systems to be. Those are just an example. I picked the top 3 that we think that we anticipate to see the future DMS system to do. One of the example is the DMS systems will have to address fault conditions and how do you manage fault scenarios. So in this case, what we're looking for is having the DMS system that allows us to look at the various kind of fault conditions and from it create any kind of data analytics from it, whether it's a machine learning or AI type approach that allows us to understand what are the faults and how do you survive from it. And in order to do that, we can no longer use our steady state modeling tools, but we need to do more of a dynamic modeling or digital real-time simulation model, which most of us do today. But for us to take that the next step after that one is how do we take those fault conditions and looking at it, the predicting what's the cascading fail when that fault happened, what's the next step after that one? Can we tie those digital real-time simulation to the high performance computing to predict the cascading failures, that events that's going to happen past that in order to dynamically modify or set up the protection system within those DMS systems. So that's the next thing that we're anticipating the advanced DMS systems to look like. The second thing is we're looking at it is perhaps taking the DMS system is the next level beyond the fault detection, but start looking at a more active grid management system. So can we look at for example, a neural network or SVM type models in order to predict and tying it to the failures and how do we manage and predict the survivability, or how do we predict the management of the system in order to go ahead, survive it up and connect it again and be operational. The third one, I think the speaker before me talked about the electrical vehicle and the challenges that we see with the electrical vehicle, whether we're seeing with the electrical vehicle and how the DMS system can play a role with that, as we're getting more managed and unmanaged charging stations becomes important to understand, because there's no way we can predict all the variation of the scenarios that those control and manage and unmanaged charging that could allows us to all the various scenarios. And in order to do that, we want the DMS systems to be able to do both the grid asset side as well as the load side and the vehicle side within the control layer as well as the communication layer integrated together in order to better understand, and not necessarily from the energy perspective. I know utilities don't like me to say that, but they can always provide more energy, but it's always the challenge is when you have many vehicle that comes in gets connected at the same time, is the instability that it creates or the power that is needed to do that. So in order to understand that, we need the next generation DMS system in order to be able to address that. I'll stop here and take the questions afterwards. Thank you.
Okay, so let me just say a couple of things about the concept of DSOs. As Mr. Suni brought it up, the whole concept of DSOs kind of evolved out of Europe. And actually in Europe, it's quite formalized because there's a whole organization of DSOs. They coordinate all over Europe, and they're trying to coordinate most of their rules and so on. On the other hand, most of the rest of the world has not actually formalized the DSOs, just like here in India. The US is the same. But we keep now talking about DSOs quite freely, even if we're not in Europe. And so what does it mean when we say DSO? And brings us back to the question of how many DSOs do you need? But there's a correlation between DSOs, DISCOMs, and DMS systems. Okay, so they won't be too far apart in numbers, right? So that's why I think many people said 70 for India, right? There's 70 DISCOMs, and though not all of them have DMSs, as somebody pointed out. In fact, DMSs are relatively new in India, but in the US for the last 15 years, we're putting in DMSs at a pretty fast clip, so that even the small distribution systems now have DMSs. Whereas here, of course, people like Tata Power and CESC have always had DMSs, but now you're seeing more and more of them. But the US, are you okay? Yeah. In the US, the number of DISCOMs is much larger. And this is a problem because, everybody thinks of the US being covered by power companies that are all large, like Pacific Gas and Electric or Commonwealth Edison or Duke Power. And they are very large. And these private companies cover about 65 to 70% of the customers total, right? But below them, there are a bunch of publicly owned, the city-owned or county-owned or those kinds of known as public utilities, and they're smaller, but there's a large number of them. And then there's another level of small distribution systems called cooperative systems, and there's something like 1,700 of them in the country. So you're talking about more than 2,000, out of which somebody like Commonwealth Edison is huge, and whereas there'll be a cooperative somewhere which is only serving about 35 farmers and nothing else. And so think of the organizational nightmare this produces in terms of things. And this is I think what Mr. Saxena was saying, that if each of these sort of comes into being organizations of some kind, and setting up the organizational boundaries and how they talk to each other and behave with each other makes the big difference. So I won't say anything more, and we'll open it up to things. But first, I want to give all the speakers a hand, because I think we could have gone on much longer listening to them. So I'll open it up now. Go ahead. There. And party last.
And after listening to Professor Bose, probably I'm a bit confused now. Without mentioning, you have given a bit of answer, and we need to be very cautious before moving to DSO. That's what you said without saying that, it's a large distribution company, and there are many smaller distribution companies, and hence probably US is slow in deploying, going ahead with DSOs because in Europe, basically all are of the similar size. So it is equally competitive. So I think maybe, I do not know, but it's a bit confusing that, whether we need to go for DSO and if we need to go, how it need to be modeled, and probably the churning should start now. And maybe next 1 year time, probably we'll come to a white paper, freezing the thought process and the ideas.
I'll let the speakers, but I want to clarify
Yeah.
one thing. What I meant was that even in the US, there are large discoms.
Yes.
Okay, and most of the customers are covered by the large discoms. But then there's a trailing end of very small discoms, and they won't impact the national policy of DSOs. Okay, they will essentially follow. Okay, but anybody else want to raise that soon?
The fundamental thing, as I understand, is DSO is not going to the asset owner. DSO is not going to do buy and sell. The way the load dispatchers don't do it. So DSO will do the knowledge part, the simulation part, reporting correctly, talking to the regulator, understanding the consumer behavior, which the incumbent utilities don't do because they're too busy with other things.
Yes.
So that's the difference between, how you are putting, I think that DSO is other than the asset, but he is very close to the entire model of the area, understands rules, regulations, markets, and everything.
Okay.
Thank you.
Thank you.
Go ahead.
Well, so continuing to follow up on his assumption that the DSO is a technical function, not a market function. Clearly, the distribution utility has the most knowledge base and probably is best suited to run and operate that DSO. But let's put an I in front of DSO, independent distribution system operator, and give them market responsibilities as well. Which one is better to promote DER penetration? The argument is the independent distribution system operator will be able to reach renewable portfolio goals much quicker than the technical system operator, which is mainly focused on operational flexibility and safety. So
Let me confuse the issue a little bit more. Because as usual, in the US, we do things a little differently. Most of the world, at the bulk level, the markets and the operators are separate. That is, if you go to Europe, there's the TSOs, but they don't run markets. In the US, it's exactly the opposite. All of the ISOs run markets. So, and to me, there's a built-in conflict of interest there, but apparently we're happy with it. So having confused you more, I think we should still answer the question about what is the function of the DSO and how do we keep this? Who wants to do it?
Sir, Sir, you have already said, sir, how can we remove the conflict of interest? How can we further localize and focus the specialized area? That's the point. So I have been a first-hand victim or first-hand knowledge of this. If you are with a large utility, say generation, transmission, everything bundle, generators will dominate. If you put transmission and system operation together, transmission will dominate. So, as the size becomes, you need to branch out. Now, the challenge before us for doing DSO would be, as you very rightly pointed out, two. Number one, the incumbent utility will say that I am doing it very well. Why do you want to separate it out? Yes. Partly correct, partly conflict of interest. Nobody wants to leave his jurisdiction. So that's the first one. The other challenge would also be there with us, which is that DSOs, people will think that it is a carriage content separation and a threat to the unionized labor and all that. So that also has to be properly convinced that we are not going to do any of those things. I stop here.
I think Gary has raised a very important point, but the report of the DSO, what the consortium has prepared, I think it ultimately envisages an independent DSO. But now we have to move in a phased manner without any doubt, because as Mr. Soni said, and we have also said in the report that the incumbent, the DISCOM is perhaps the right entity to start with. They have the knowledge, they have the tools, they are best placed to have the knowledge about the ground reality, the consumer at best, and arm them with sufficient automation, instrumentation, and tools. Let them do the decision making, and gradually we evolve. Who does it? And ultimately we branch out to the independent DSO. But I think as we have seen, everything anywhere takes about 10 years. I think just giving an example, when I was in Norway some years ago, Nordput people think that another batch from India learning about the market. And then he very sort of sarcastically asked how many years you people will take to bring the market in the India. So I asked him how many years it took you. And it almost took them 10 to 12 years. So I think similarly, it took us. I was just talking to some people yesterday, National Open Access Registry. It took almost 12 years for us to bring it. So similarly, it will take a few years for DSO to come in. But the case we are making about in the report is that there is a need for DSO. It is a specialized function and it needs to be looked at in a specialized manner. Number one, who's best placed to do it today? No one size fits all. Do it as per your needs, as per requirement. Who's best placed to do it today? We have done some sort of a simulation or whatever. We have done some clubbing about that. Wherever the renewable penetration is highest, wherever the EV population highest, where the DR population goes to be highest, they should be the first starters, and then we should go in a phased manner, etc. So I think the roadmap has to be there. I think the learning, has to start, and we feel some of the utilities are best placed to take on the DSO as the first entity. I think. And maybe the private utilities are best placed to move on very quickly. Thank you so much.
I think what you name it, DSO or IDSO, brings back a story. 15 years ago, when sort of this move for putting in more DMSs started, and then somewhere along the line, about, I think, 8-10 years ago, people started talking about ADMSs for advanced DMSs. And now, of course, if you, everybody wants a DMS. Nobody wants a DMS. And in fact, nobody sells a DMS anymore. Everybody's DMS is now called an ADMS. So next question.
Yeah.
Go ahead.
Thank you. I think part of the comment that I was going to make was answered by Mr. Suni. Is I think if you look at the institutional mechanism through which this would be implemented, it has to be implemented at some point of time. And the time scales in our case are, like Mr. Saxena said, is at least a decade, maybe multiples of decades. Now, but the important point is to get the political acceptability of even this idea is not to give this impression that this is in the context of carriage and content separation, though it might be required from a different point of view. Because remember, everybody wants to protect their turf. They don't want anybody else. So requirement is from the system operations point of view, from the flexibility that it can bring to the system, distributed ancillary services, integration of RE. That is the key points. Anything else we would like to bundle with it as of now, even though retail competition is being mentioned in the, now the amendment which is there. In fact, Mr. Suni, that the bill which is there, it's already allowing now the NLDC to trade in the market. And that is from the ancillary services, I think, point of view it has been given. But it's a draft. It's a bill now. It's not, it's a bill. It's there. So I'm saying is you never know how it evolves in future, but if on its pure technical merits, it will always be required. Thank you.
I think my question is for Mehta. I think great discussion on the Gujarat utility. I think in US certainly time of use has been something implemented by big IOUs. I'll make that point to Bo's point there. I think at least big utilities are driving EV behaviors and some of the consumer behaviors. And I know it's probably a temporary solution. I was wondering what is that impeding those kind of solutions here in India? Just curious if you have any thoughts.
No, sir, as on today, no TODs except the industrial. There is a night tariff is a separate. And there also I will take 1 minute to explain. Say in Gujarat, we had a very huge capacity surplus during the night. So we introduced LTP4, one special category to use power only during the night. We announced very huge way. What we end up with what? The people were using the power during night, they started paying us less and we did not got any more load benefit in the night hours because people do not want to compromise on their comfort level. So these are certain practical. Even if you see the holidays, any Dashera or any Holi or any, there's big drop in the demand. Even with whatever concession you announce, people will not use power. Next day they want 15,000 megawatt. So these are practical challenges. But TOD has to, TOD will only bring some commercial aspect in that.
Any more?
Or anybody from the DISCOM, would you like to say something that how do you feel about DISCOM? Not the question, but your impressions about that the DSO concept and how the utilities should be. Are they gearing up? What is your impression? Not about your own utility, general impressions and what should be done to promote it.
Up towards the kind of requirements a utility has to have to become a DSO from DISCOM to DSO, like normal SCADA now coming to ADMS, not DMS, ADMS. We are also working in ADMS form, and we are doing a lot of functions which we discussed during the sessions like forecastings and load research. Those things we are already doing. But point is, soon we need to move to a new role of the DSO, and sooner or later we have to live with it. So better we prepare now.
Sir, just to update the August gathering over here in Gujarat since 2005, the DSOs are, all 4 government DISCOM DSOs are working as a subset of SLDC. And they are almost doing all this demand forecasting, load restriction implementation, voltage profile at the distribution level monitoring, etc. And in Odisha also, after taking over by the Tatas for all 4 DISCOMs, they have their own control center and they are doing more or less work of the DISCOM as DSO as on today.
Sir, I would add only one thing, sir. As far as the hardware is concerned, software control center, anybody can have it. Let everybody have it, no problem at all.
Yes.
But it is the how you think about it. How do you remove your conflict of interest? That is most important part. The same tool, a generator will ask load dispatcher that ensure that my generation gets dispatched. Transmission company will say so. Whereas the load dispatcher has to think about the whole thing. Same tool, same software, same hardware. So, just because I have all the tools, I do not become a DSO. In fact, I become worse. A DISCOM equipped with everything and not doing in a fair, neutral fashion is the real tragedy. That's the point, I think, yes, very important one. So that culture has to come. They have to have a different gene altogether.
I think Professor Abhyankar said something about social. The social benefit is finally who's looking after the social benefit. If the GenCo is only looking after making money for paying, who is looking after it? And you do have to have somebody who doesn't have conflicts of interest, whose job is only to do the social welfare. And we have, I think, in the back of our mind, at least all of us engineers, think of that as being the operator. The system, the transmission operator, the distribution operator, and so on. So go ahead. Oh,
I have a curious question. I don't know how to spell market, so I won't ask that one. But what I want to ask is, China is something nothing was said about it. They are the same population wise, same as India. Give a few billion, this way, million or some millions, but they they have the generation capacity same as like US. So is there any lessons to be learned from how Chinese manage these things unless they keep everything secret? I don't know. I was wondering why we all talk about Europe, India, and US and so on, but is there anything that comes out of China? I don't know.
do you want to try?
Anjan, you go to China very often, right?
So I haven't been there, and I don't know when it'll open up again. But you know, this is what I meant by the structure of every country is different, and that makes a big difference. And I was actually going to ask the panel about the fact that the bulk power system in India is at the central level, whereas the distribution level is under the states, right? And this is a big issue for us, but let me answer the Chinese thing. In China, everything is the same. You know, you go to the smallest village in China, the biggest building says state grid on it. In fact, the biggest Pakka building is always the state grid building with the substation next to it in the smallest of villages. So you see, everything is done top down. And that gives you, you know, somebody said about central and decentral. Well, they don't believe in decentral. So, but going back, I'll throw that question out to the panel about the fact that here, you know, the states make their own decisions about discoms, about this thing. And one of the recommendations we made recently from the National Academy, we had a workshop on the policies and regulations and operations. And one of the main recommendations was that somebody's got to coordinate these regulations between the central level and for us for 50 state levels. You know, that's a lot of people to coordinate, and I'm not sure how it can be done. But if you don't do it, you're going to end up trying to manage DSOs that are doing different things. You know, and so I'll throw that up to the people here.
I would just say that there is a very important need for a harmonization of regulations among the states and the distribution companies. And India, fortunately, we have got a setup called Forum of Regulators, wherein the chairman of all the state electricity regulatory commissions, they are members of that Forum of Regulators. And this is chaired by the chairman of the CERC. I think there is a harmonization of regulations to the extent it is possible. And the FOR has brought out a number of important model regulations, important reports. Some of them, Mr. Soni has been sort of a contributory to that. The Samast report, the Kabul report, that is on scheduling, metering, accounting, forecasting, capacity building, a number of them are there. So I think there is a need and it is in place in India. Now the question in India, one has to look at that electricity in the concurrent list, where the central government as well as the state governments can make the laws in regard to the electricity. And that is why it takes time, like the states may move with different speed depending on their own sort of a setup, which is their resources they have, the speed with which they can move. And apart from all that is the political will to move forward, particularly in the new and emerging technologies. So that's what it is. Thank you.
Yes.
Sir, I will only add two things. That this DSO to me is not a technical problem at all. It's an organizational engineering. It has more to do with governance, how the things will be governed. And as far as the coordination you said, sir, it is absolutely very important. Mr. Saxena mentioned about Forum of Regulator, which is as per in the Act itself. But amongst the load dispatchers, we found that there is a room for coordination. Yes. So we created a Forum of Load Dispatchers. which is the. So going forward, there has to be a forum of DSOs also where they will be coordinating. But let there be so many DSOs first. No, it should not come under fold. Fold does at a different level, sir. And DSO's problems are completely different, sir. Sir, I tell you, sir, I have done a survey, very quick survey. The mindset of load dispatchers also. SLDC, he is worried about 132 kV, 100 megawatt also he is worried about. You come to RLDC, he is worried about 500, 400 kV, that's all. When you come to NLDC, he doesn't bother about 500 megawatt also. So he is only talking about 765 kV, HVDCs and big things. So when you go to DSO, he has to talk in terms of kilowatts, in terms of 11 kV. That requires completely different skill set, different mindset, sir. That's the point, sir. Thank you.
Okay.
Any institution set up for the distribution sectors separately for looking after these market models? Like,
Yeah, to be honest, I don't have answer to your question. So what we are currently doing is just, speculating and putting up proposals that if, let's say, we have to have a common platform at the local market level, how that platform would work, general principles of the same. If not, then if there is any P2P type of a setup, what could be the rules, regulations, and terms, conditions for the same? So at this stage, in our report, DSO report, we have enlisted what could be possible, avenues of doing it, and what are the attributes of the same. Now, this is open for discussion, debate.
Forward, we lack inertia in the system, right? So how do we manage that? With DSO, can we able to, maintain that virtual inertia, the support of DSO? Or is there any regulatory norms that need to be made to have a sufficient virtual inertia in the system?
I think there is no norm if you are talking of the inertia at the distribution level. I think it's inertia, people still are not realizing the value of it in India. I think people feel that it is something which we will talk about, we'll think about. So I think this is, if we have been from the Terry side, with whatever little work we do, we try to bring about the value of the system stability and the system sort of these studies to be there. Everybody is talking of the capacity expansion and the optimal dispatch. That is what it is. And we are all saying that by 2030, these many about 450 gigawatt, 500 gigawatt, that can be there. And we tell that the machines will be able to go to the technical minimum or not. If not, what compensation is required by them, etc., etc. But nobody is talking about the stability. We at Terry has brought out a 2030 decarbonization roadmap. It is available on our website, and we have flagged the issue of system stability. So we are not even talking about the overall level. So at the inertia, at the distribution level, I think it's a bit far to think about. Thank you.
Anshin.
So,
Go ahead.
let me just finish up this one. As Saxena said, usually the distribution operator doesn't worry about stability. It is more of a bulk phenomenon. But what I'm hearing is that this increase of a lot of IBR connected things are causing some oscillation problems, which we do not have tools to handle yet. We are just somewhat powering through these things right now. And we don't even have the models. We don't even have the everything here. So there's, this is one of the things, when you change the system, there are problems going to arise that you've never thought of. And that's what's happening at this stage. So there may be, but the stability of the system is not going to be affected by the DERs on the distribution side. Sorry, I cut somebody off here. Yeah.
Right. So the primary function of the DSO always and forever will be safety and reliability. And scenario planning in the past to maintain safety and reliability operationally if you're in the control room real time. However, with that being said, as the planning of adding DER becomes more complicated, the scenarios to maintain the reliability of that DER becomes more complicated. So maybe we could speak to, are the distribution system operators ready to put a test engineer into the control room real time to do scenario planning? And Rob, are the tools available to automate a lot of the scenario planning so that the distribution system operator can focus on safety via alarms, automation, things like that? So maybe, is an engineer required on shift now? And are the tools going to help act as that engineer? So
With that, I think we'll have the next question over team. How's that? Thank you very
Yeah,
much.
just last one, sir. Yeah, I mean, thank you very much, Professor Bose, for conducting a wonderful panel, and I'm very happy about it. Only thing, my request to Soni ji and Saxena ji, please don't make it 10 years, make it within 1 year. Let us do something in 1 year. Please, yeah. Thank you very much. You spoke my mind. Yeah, thank you. Thank you. Thank you.
Yeah.
Can I put one question in there?
So the discussion will stop.
We talked about DMS, we talked about going ADMS. So I think with all the changes coming up, we need A squared DMS coming up.
That's an equation.
That is.
So those who can come here, we can have.
Oh,
Please come.